Hello students, welcome to In 5 Minutes. Let's start with the second sum of the type 2, that is from minus pi to pi. But here you can see my range is splitted. For minus pi to 0, my function is minus pi, and for 0 to pi, my function is x. Let's start with solution. So initially I just write f of x, that is a0 plus summation an cos nx plus bn sin nx. So that is nothing but my Fourier series. So I'll be first starting with finding a0. So my a0 is given by 1 upon 2 pi minus pi to pi f of x dx, which is equal to 1 upon 2 pi. First is from minus pi to 0, my function is minus pi dx, and then from 0 to pi, my function is x dx. So I can solve this. Then my a0 will be 1 upon 2 pi. By solving, first will be minus pi x. My limits are minus pi to 0. Next is x square by 2. My limits are 0 to pi. That substitute, which gives me 1 upon 2 pi. Here minus pi is a constant. Putting upper limit, which gives me 0. Putting a lower limit, which gives me minus pi, plus 1 by 2 is a constant. Putting upper limit, it gives me pi square. So finally I can say this as 1 upon 2 pi. This comes to be minus pi square plus pi square by 2, which comes pi square by 2 minus pi square. Finally I get as minus pi by 4. So I get a0 as minus pi by 4. In the similar way, we'll be finding an. So an is given by 1 upon pi minus pi to pi f of x into cos nx dx. So let's substitute that. I get as 1 upon pi. First is minus pi to 0. My f of x is minus pi cos nx dx, and from 0 to pi I get x cos nx dx. When you solve this, you get 1 upon pi minus pi is constant, integration of cos nx is sin nx divided by n, where your lower limit is minus pi, upper limit is 0, plus you can say here this is u and this is v. We can solve as u into v. That I get as x cos nx integration is sin nx divided by n minus 1 into minus cos nx divided by n square, where your lower limit is 0 and upper limit is pi. So after substituting, I need to substitute upper limit and lower limit. So here minus pi by n as constant. When you put 0 here, sin 0 is 0, and when we put pi, that is also 0, which comes to be finally 0, plus when you put pi, sin n pi as 0, minus and minus becomes plus, cos n pi becomes minus 1 raised to n divided by n square. That's my upper limit. Putting a lower limit, this becomes 0, minus minus plus, and again cos 0 becomes 1 upon n square. So now after solving this, you get an as 1 upon pi, this has 0, and here what is remaining, that is minus 1 raised to n minus 1 whole divided by n square. So where I can write this will be equal to 1 upon pi n square minus 1 raised to n minus 1. That's my an.